My name is Rod, as I was introduced, and just a quick thumbnail sketch about me. I've been involved in information technology in a variety of roles since about 1975. I got my start in a mainframe environment, wrote my first program my first Fortran program on a card punch and ran it on an IBM 370. And throughout the years, I have been always associated with technology, often been an early adopter of technologies as they come out. So, for example, I was involved in artificial intelligence back in the 1980s, got involved in a lot of the open source software when it was still considered a very strange concept. I've worked in a variety of roles in the industry, from programming to design. My primary background is as a mathematician and anthropologist, cognitive scientist, but technology has always been an integral part of what I've done, from project management to working at the various dimensions of the industry. I've particularly been involved in new product development, managing teams, and like I said, have always been an early adopter of various kinds of technologies. So I've seen the cycles of product development. I've also seen how things have been successful, but even more importantly, sometimes how things have been failures as well. So in this webinar, we're going to be taking a look at one of the current trends and an explanation of some of the dynamic factors that interact with this. And we're going to be talking about mobile first strategy, why that is becoming increasingly important, and also a little bit about the minimum viable product cycle and why that is also important and why that is happening today, and what the full stack concept, how that full stack concept interacts with both of those, and some of the benefits from the full stack development. So we're going to be taking a look at an interesting trend in the IT marketplace. I shouldn't say the IT marketplace, but the marketplace in general, which is driven by IT, as opposed to the marketplace is driven by IT. First of all, this concept of minimum viable product is fairly interesting, because this seems like a new concept that's come out of the lean startup, lean entrepreneur, lean engineering world. But in fact, this has been something that is been around for a long time in various forms, one to the other. We've always been asking the question, what is it that actually what are the products we actually need to deliver in order to be successful to our customers? And the standard wisdom, received wisdom for decades and decades and decades has been, well, you've got to give people what they want. In the 1980s, this was expressed through things like the Tom Peters approach and the in search of excellence ideas, where it was stay close to your customer, get inside your customer's business, understand what they're doing. It always comes down to a matter of understanding what your customers need, what they want, and then delivering something that aligns with those and not wasting your time producing things that nobody's really interested in using. The problem has always been that it's hard to know exactly what the customers want. So we often have found ourselves in development cycles where we've been producing products on kind of a blind guess. Sometimes we'll do some market research and we'll throw it out there, and then we'll suddenly be surprised to find it doesn't work, or when we throw it out there, we get surprising responses. So for example, the chairman of Sony was asked when he first introduced the Walkman, wow, what was in the market that led you to what market research did you that led you to know this would be successful? He said, we had no idea. We weren't going to go around and ask people, hey, do you want to strap a tape recorder to your belt? Because when we said that, people just laughed at us, but when we put it out there, people used it. So the problem here is that it's very difficult to get timely feedback on products. We eventually get feedbacks. People don't use them, or they use them. Facebook was an example of something that certainly I never thought was going to take off. But of course, that was a great example of me being absolutely wrong. So the problem is this: in order to make the business leaner, to make the business more focused and successful, we start to really focus in on the idea of getting a viable product out there early and fast, and then start to work with the feedback that comes through as the customers start to use it. So we've got the idea for the product. We then want to build the product get it out there, see what happens, get the feedback, which means we've got to have that connection. We gather the data, we learn from it, figure out where we're aligned, where we're not aligned, and then refine the idea, and we go through this continuous cycle. So we're having this iterative product development approach. And like I said, this idea has been around for decades, but it's only been in the last while, as we get into the era of digital transformation, that we're able to start really speeding up this cycle and not wasting times going off on tangents in terms of product development that have nothing to do with what the customer actually wants. Now, this idea of iterative product development also fits in nicely with the ideas of iterative software development. So this comes out of an approach in the agile methodologies, where the various agile methodologies in the 90s that were there, although they didn't call it agile at the time, they later got together and decided, oh, we're all doing very similar things, so we'll call, and they needed a name for this kind of common approach, and they called it agile. And one of the things the agile approach says is that they said two things which fit in with that MVP approach. And the first one was you interact with customers on a daily basis. Now, that's important because what that does is produce regular feedback on what's going on. And the second thing that Agile says, which is very important as one of their basic principles, is that working software is the only measure of development. In other words, you're constantly getting things out in front of people, getting it in their hands, and then you're constantly talking to them and getting feedback. And so Scrum, as an example of an Agile methodology, illustrates how we adapt a development process into that minimum viable product framework. So we start off with our product owner, who's a representative or a stand-in for the customer, and we basically come up with the initial idea. So wouldn't it be nice if we could do this? Oh, here's a great idea. Here's a problem we've got. How can it be solved? And so what the team does is it starts to lay out some iterations, some sprints. We're going to be doing some releasing every 2 to 3 weeks of a particular version of the product. Let's look at the most important things the customer wants. Let's put something together that they can actually get their hands on and work with it. Maybe we only get 10 to 15% of what the customer eventually wants, but we'll get them the most important 10 to 15%. And so we set that up as our goal for the sprint. That's what we put into what we call our sprint backlog. So our sprint planning meeting is telling us, what do we need to do? What's the most important thing we need to get out there? So we put this onto our to-do list for the sprint. And then over this 1 to 4 week period, we go and we produce something that works. While we're doing this every 24 hours, what we're doing, the Scrum Master is basically the coordinator, the overseer, the taskmaster, whatever you want to call it. And every day the daily Scrum meeting is taking place, where we're figuring out how can we do this better? Are we on track? And there's a collaborative effort between people representing the business side, the testing community, the developer community. And after a while, you wind up showing the intermediate results, getting feedback directly from the client. Then you go back and you do it again. You say, okay, they liked 80% of what we're doing. They did like the 20%. We'll rework this 20%. But now we can add another list of things into that product that they want. So this cycle proceeds until we finally get a finished work, which is a minimum viable product, but it's gone through a number of iterations on its approach to that, so that people have had something to work with in terms of being able to decide, is this working for me? Is this not working for me? Very often, the only way that we know if we're on track is when we get something out there and get it out in front of people. So there's the idea of the sprints. So each sprint has got the same plan. We're thinking, what are we going to do? We're going to design what we're going to build. We actually develop it. We test it to make sure it's working. We deploy it out to the customer. And then the important part is that we sit with the customer, in figuratively or literally, and say, okay, so what do you think? Where could it be better? What are we doing right? What are we doing wrong? And that goes into the next iteration, and we're continually getting until we finally get to the release that comes, that we've been able to ensure is on track with exactly what the customer exactly what the customer wants. Now, the interesting thing about this is that this approach is not just in Agile, but we see a similar approach occurring in what we call design methodologies, like the Stanford design process, the Delft design process, in which we talk about immersing ourselves in a problem, coming up with an idea, testing it, and then deploying the idea, and then again immersing ourselves in the problem in an iterative approach. All of these approaches are just different ways of saying the same thing. Really understand the customer, whether it's by daily meetings in your Agile methodology or by immersing yourself in the problem from the design perspective. Come up with an idea that solves the problem, is motivated by what the customers are saying. Produce something that looks like it's going to meet that problem. It's a first approximation, but you've got to make something, get it into the customer's hands, and then evaluate how well that's working, look at the lessons learned, and start and do it all over again. That's fundamentally the idea that drives all of these kinds of approaches. Now, in order to do this, it just doesn't happen magically. You have to have the right people in the right spot. This is, as Agile approach says, the key to success is to have people who know what they're doing, and let them do their jobs so you can get technical excellence. This is driven by skill sets. It's driven by the skill sets of the product owners or the business analyst being able to really ask the right questions and understand what's going on with the customer. There is a relationship aspect to this. There's also getting the right people to do the right architectures, to come up with the right code. One of the things we want to avoid is rework, where we're constantly going back and fixing stuff that should have been done right the first time. And we also don't want to get involved in working with technologies that are cumbersome and take up a lot of time and are very difficult to work with. So what we want to do is we want to get the right skill sets, and we also want to get the right technical environments so that we are able to do what we just talked about, this ability to get things out the door quickly. What has evolved and emerged in the IT development community is this notion of a layered architecture. And this becomes a reusable architectural model that has a lot of value in really dividing up the kinds of elements or subsystems or components that are actually required to produce some kind of viable product. So we have a presentation layer, which is the layer which really the customer or the user interacts with. This is where they open up the application on their phone, or they open up the application on their desktop, and they're interacting directly with the application. Now, of course, in the customer's minds, that is the application. So, for example, it's surprising how many people, when they're using a phone or a device, think of the data that they're actually interacting with as being on their phone. So the presentation layer, there's a variety of technologies that are used to render or provide a user interface or user experience to the customer. The service layer is the layer that actually takes the interaction with the customer and turns it into a task that needs to be executed. So if somebody is going to go and do a search, the presentation layer is the interaction where they're able to get into the search box and enter the request. And then when they hit that submit button, it goes to the service layer, where the request is turned into a task that needs to be accomplished by the system. But not all tasks can be just executed directly. So let's suppose we've got a bank application, we open it up, and we want to pay a bill. So we hit the task of the service layer to pay the bill, but then it's got to go through the logic layer to figure out, well, exactly how is that task going to be done? There's banking business rules, things have to be routed to certain places, and so there is an underlying layer of activity that has to take place at the business layer, which actually figures out how does that service layer, that task requested by the service layer, how does that actually get done? What's the underlying business logic? What are the underlying business procedures? And then that has to say, well, if we're going to do this, we're going to go and have to get the data that we need in order to get this task done. Like we're going to have to get the information about where the account is that you're paying the bill to, where you're paying it from, your bank account. And so we have to be able to go and find the data and bring it into the application. And then at the persistence layer, once we're done, that data's got to be saved somewhere persistently. There's got to be some actual location of the data. So when I look at my bank account, I'm seeing it on my phone in a lovely late. I'm seeing it in a presentation that makes sense to me. It's easy to use. The service layer shows me all the things that I can do, and when I actually hit something on the service layer, the bank, business logic and the application logic or the functional logic then figures out what needs to be done to make that happen, and that goes out and fetches the data from various places. Once we're done, there's a nice record of it somewhere in some database. And as a user, I'm really not aware of anything other than the presentation layer. So this is a stack of different aspects of a problem that have to be done. And that this is emerged as a fairly standard way through experience of how we present applications out to the user. This always hasn't been standardized. It's something we learned through often bitter experience as we were trying to figure out through the 90s and 2000s, how do we actually deliver on these e-platforms to the kind of experiences that make users actually want to use our products or services. So in order to develop this enterprise layered architecture, we have what we call a full stack development. And what that means is that within the delivering of a web application, which is the most common way we do this now, almost overwhelmingly, in fact, there are a variety of tools that all merge together to create a tool set or a toolbox or a toolkit, which allows us to attack a problem in terms of those layers we just looked at. So this is what we call the full stack. We have technologies that work at each one of those layers of the application. For example, in here we've got front-end tools to work with the presentation, cascading style sheets, HTML, JavaScript, Angular. We have technologies that allow us to organize our work, Scrum and test-driven development. We have design, which is user experiences, user interactions. That's sitting there on our phone or on our desktop. Databases. Different kinds of databases. For example, there we've got PostgreSQL as a relational database, Mongo as a NoSQL document database, Elasticsearch, and a lot of these other caching and other kinds of technologies that we use. The back end, how is the logic actually working? For example, Python, Node, Java. Nowadays, we're also seeing Go and other languages. DevOps, automation tools that we use to speed up our entire process, including things like getting stuff up in the cloud and development tools like Git for code repositories, Gulp as a way of doing builds and getting builds delivered, plus all other kinds of things as well. So this is focusing on our development. All of these technologies are coming together. Notice a lot of them are actually actually interestingly open source technologies. In fact, this is generally the characteristic of most of these development stacks, is that there is, in order to achieve this common currency in the developer community, these tend to be freely available for people not only to learn, but to use. And that, of course, is one of the more interesting trends in terms of the economics of computer technology. You don't make money unless you make stuff available for free, which is kind of interesting. So in terms of the people skills that we need people who are going to be able to work in each of these layers. We're going to need people that are going to be able to work at the operating systems level, whether it is with a Linux for our standard LAMP stack we're going to see in a moment, or people that work on an Android platform or an iOS platform or some other kind of system. So we're going to be able to have the expertise to deliver on the various platforms that are used in our marketplace. We're going to have people that are experts experience in databasing, and that just doesn't mean writing SQL code. That means actually being able to sit down to build effective data models, build an actual database system where we're able to access, manipulate, and work with the data in a highly efficient and effective manner, often creating very nimble and agile kinds of data models. Web servers, be able to think about the issues involved in delivering applications, and this is where we get into issues of loading and stressing, and this is where also things like CloudFront in Amazon and the similar technologies and Microsoft Azure and other other cloud providers talk about being able to to get stuff to the customer quickly. Are we going to see the same levels of performance when we have 2 million people accessing our application at the same time around the world, as opposed to when we have 5 people accessing it from our local office? Server-side code. The servers are going to require massive amounts of code at that application and business logic layer. Do we have people that are skilled in doing good program design? One of the things that often is overlooked in the agile world is that in order to be very nimble and agile and constantly be changing our application in response to feedback from our clients, we have to have very, very good and modular design that we can change without having to go back and create problems and rework. Browsers, there's the experience, and browsers generally are going to be not just the actual browser itself, but all the technologies that go into the browser, being able to build cascading style sheets, responsive environments, and client-side code. What's all the stuff that sits in the browser that actually provides that functionality in the client end through technologies like JavaScript and related kinds of technologies. One of our traditional stacks has been the LAMP stack, and this was pretty much dominated the industry for a while, in which most of our servers were, or in fact, our choice of server was primarily Linux. Because it had that durability and it had that functionality we needed at a server side, as opposed to something like Windows, which was primarily designed for the end user. So Linux powered our server. Web server was Apache. The database at the time of choice was MySQL, and then very often PHP, and later on Python, and Perl goes way back early in the that was the original CGI functionality we had going back to the 90s in terms of web applications. And we still have a great deal of installed LAMP stacks out there, although that the M often has been replaced. So MySQL, after it was taken over by Oracle, then did a fork into Maria, but PostgreSQL also has stepped up into that place as well. So we'll often see those in the LAMP stack. Now, as a result of this, there's one thing we do want to look at. We've been looking at a general trend towards moving towards a JavaScript-based stack. But one of the interesting things you can look here is the languages that enterprise look for as a reflection of what's actually going on in stack development. And we'll notice here that JavaScript is really, really high on the list, and that's a reflection of the fact that the JavaScript-based stacks, which we're going to look at, the mean stack in just a moment, are really starting to come into a industry-leading position in terms of choosing a full stack development. Java is still up there, like COBOL. It was a language that people went to, particularly developing LAMP stacks. Although we have a lot of PHP, a lot of the business logic that was going in the lower levels that we looked at at the back ends were, for example, persistence was often done in Java. So there's a lot of installed Java code out there. Just like there's a lot of installed COBOL code, a lot of that is legacy code, which accounts for a lot of it, but it's still a significant, language out there. Python has really experienced a resurgence in the last few years because with our emphasis on data analytics and artificial intelligence, machine learning, what Python has done is because of its access to the various toolkits and interfaces to various machine learning systems, Hadoop and other big data environments and its libraries, it has become the general language of choice for people working in analytics and big data. C++ and C are generally still up on the list. They represent a lot of embedded systems, mostly things like sensors, embedded software. That's their space. They don't really enter that much into what we're talking about today in terms of delivering products. The reason why they're there is because they serve a very important role. For example, when you're designing a missile guidance system or you're designing a satellite, and you've got to have code running in there. Generally, we're going to see be running on C and C++. C# is the Microsoft version of that in a sense. PHP, again, has still got a lot of legacy applications out there. Although people are migrating away, there's still a lot. And we've got a couple of the emerging languages. R, for example, is emerging simply because it's again another language which is very, very effective for data science. Scala is coming up a lot simply because it's a language which is used a lot with Spark and a lot of big data analytics. Swift mobile platform Go, a recent innovation over the last number of years from Rob Swift, who invented UTF-8, and Ken Thompson, who was one of the original authors of C, is been entered into the server market and is really growing by leaps and bounds. So Ruby and some of these other things, for example, we are seeing some Haskell and other things like that because they're specialized markets. But you'll notice that overwhelmingly we're seeing that JavaScript in that marketplace. Now, this is partly driven. These things are sort of shall we say, closed loops in a certain sense. There's a lot of JavaScript developers out there because there's a lot of demand for JavaScript out there. But when people decide what kinds of stack they're going to use, they'll often see, oh, we've got a lot of JavaScript developers, so we're going to go with me. And so this becomes a self-reinforcing cycle. If I'm going to go and implement a stack, I'm going to look at what resources I have available, and particularly in expertise. Because remember, going back to what we talked about earlier, we've got to have good people to be able to get that tight development cycle. And so what we tend to have is this this notion of a mean stack. So we have a client, and very often we'll use Angular, which is a JavaScript-based development environment, which, not development, but I'm sorry, a website to produce a particular website. Then we have the user interaction layer. We get our parsing requests. Requests are being made where we're working through a Node.js environment with another JavaScript environment. We're using JavaScript on that. Then we wind up getting the data through Express.js, and we're then talking to Mongo. Now, Mongo is interesting. It is what we call a document database. And the way that data is stored in Mongo is we basically took the way that JavaScript stores objects, which is called JSON or JSON, JavaScript object notation. And what the MongoDB project did was take that JSON JavaScript model and then just turn it into a more efficient model, which was called binary JavaScript, which is called Bison. And so what happens is that we've really seeing the similar kinds of approach right into the database, where we might almost call it a JavaScript inspired kind of database. And then, of course, on the return, we see the return path of the request. So now we're going through the stack. But the thing that's interesting about this mean stack is that it's JavaScript all the way through, from the beginning right through to Mongo, which isn't pure JavaScript, but is certainly inspired or used by JavaScript. Now, the interesting thing about this is that this mean stack and the fact that it is basically a JavaScript-driven stack has gotten so much popularity that when we just look at where it's being used, of course, all of these are pretty big names in the field, from Gmail to Dow Jones, PayPal, Uber. I mean, if you haven't heard of most of these, then you're clearly living in some kind of monastery somewhere. I mean, so we're talking about the fact that if these organizations are using it, they wouldn't continue to use it if it wasn't producing some kind of viable results for them. And across the various industries, we're seeing the same kinds of adoption rates. So what we're looking at here is an industry validation that this mean stack is producing results. So why? Well, one of the reasons is one language to the development journey, is that we're not switching from technology to technology. We're not going from Java in the business world to PHP in the presentation layer. We're sticking with one basic programming language. What that means is that we have a larger pool, or we have access to a larger pool of developers and skill sets, which means staffing and skill-based tooling becomes a lot easier for us. And we're also going to find that because we've got one language throughout the development journey, we're going to have much more flexibility in moving people around on a project from part to part. It's cost effective in the sense that, number one, it is open source, but the other, which relates to number three, for good support throughout. What that means is that because so many people are using it, it becomes a language that a lot of people are writing support tools for, ranging everything. Even Angular was written because JavaScript was becoming a very important development language. But at the same time, because Angular became a very nice development platform, more people started learning JavaScript so they could use Angular. So again, there's that self-reinforcing cycle. It's built for the cloud. I'm going to say a little bit broader than that. Because when we think of cloud, we think of AWS, Microsoft Azure. I would say it's more built for the overall web, of which the cloud is part. This JavaScript started as a web scripting language, and it has its roots in web-based development, and that, of course, includes the cloud. It also makes our code isomorphic. What that means is that, again, we're looking at the same kind of code all the way through the stack. Isomorphic means the same. So we're looking at JavaScript code, whether it's the front end, the back end, whether it's working with the database access, whether it's working with the business logic. We're seeing the same code all the way through, which again goes back to our benefits of being able to have much more portable skill sets, being able to use much more portable tools and that sort of thing. It also allows us to produce single page applications, which in our mobile world is increasingly important because we don't want to keep reloading pages. So in fact, our whole application just works in one page, and we see the page mutating or changing seamlessly as we move from task to task or step to step in a particular task that we're working in. There's a couple of other interesting trends that we're starting to see, which also are reinforcing the use of the mean stack, and in particularly web-based stacks, web technology-based stacks. First of all, there's a social aspect of it. 76% of businesses are using social media for business objectives. There is an increasingly blurring of the categories of web for business versus web for social interaction. Businesses are finding that the more that they evolve a social media presence, the more that, so for example, just one small example is that many businesses, monitor Twitter, and when people have complaints or issues about their business, you'll often see companies and organizations responding. So, for example, I remember one I saw where somebody complained that they ordered something at a Wendy's burger place, and the service was terrible, or there was something terribly wrong. And Wendy corporate immediately responded to that and say, "We're sorry you had that experience," and resolve the issue right there. So businesses are finding that. Remember, we talked about feedback, the importance of getting feedback for things like viable products and services. Social media provides that channel that businesses can actually do that, get that connection with their customer. Mobile, 70% of enterprises cited improved productivity as a driving factor. And one of the things that we find with mobile is that increasingly we're in a mobile-based world, and we'll talk about why in just a moment. Analytics, well, remember the other part of that cycle was finding out what people want and what people are doing and what's working and what's not working, and that's what analytics tells us. One of the interesting aspects of analytics is that people tell us they're doing something, but when we look at the data, we realize that what they're telling us they're doing and what they're actually doing are different things. And we want to be able to respond to what they're actually doing, not what they just say that they're doing. So analytics has become increasingly important. And that's incredibly true now, or even more important as we get into big data, where we have massive amounts of data and we have to be able to extract the relevant information from that information. And cloud, perhaps one of the more underrated technologies, is actually changing how we use our development infrastructure. The cloud is probably one of the most amazing parts of this whole approach, because it's particularly with mobile, the ability of the cloud to be able to do very, very strong or very, very, shall we say, effective mobile development and distribution using things, for example, at AWS, using CloudFront, we can get mobile services, and other mobile services that are built into the cloud platform allow us to get applications up and running very quickly. So the cloud environment has all of the tools that we need available. We don't have to provision a development center with all of the tools that we need in order to get mobile applications, for example, out there. It's all there in the cloud, and we can basically go. For example, Time, the Time Magazine Incorporated, found it was so efficient. They moved their entire IT operations into the cloud. Walmart has moved a lot of it into the cloud. Most large organizations have moved significant portions of their activity into the cloud, simply because that's why we're looking at 92% of businesses there. Not only that, it tends to improve costs. The cloud tends to be a lot more cost effective. In addition to this, we have another interesting phenomenon which is occurring, which is the Internet of Things. Now we're getting not just web-based applications that users are using, but we're getting interaction from mobile devices, from sensors, from cameras. Every time somebody does something, some event produces data, and it's all connected through the Internet of Things. So we can, even for example, with 3D printing, we get into situations where somebody can go onto their mobile phone, choose a product, order it. It gets sent to a 3D printer, down the street from them, and they pay through their mobile app onto the banking. Through their mobile banking app to the company, and go down and pick up their product from the 3D printer. We're looking at a complete revolution with the Internet of Things, the cloud, and some of these other technologies converging together. We are starting to see a real transformation in how things done. One of the more interesting aspects of the Internet of Things, particularly when powered by things like the cloud, is that it has the potential and is completely revolutionizing the notion of a supply chain. Which levels a lot of the market, the playing field on the market, because you can now start to look at moving into a market without having to establish very, very large, expensive logistical infrastructures. So this is another very interesting aspect of this. An interesting little item that came up just on the news the other day. This is during the time of the coronavirus epidemic, and there is a shortage of certain kinds of medical equipment, and a number of companies have switched over and started producing this using 3D printing because it's so fast rather than building traditional supply chains. So we're seeing many, many examples of this. This is also coupled with this incredible rate of mobile adoption, where we're seeing mobile becoming the preferred platform of choice. There's a couple of demographic reasons for that. Reason number one is that it is an inexpensive entry point, and it is you can have a much higher volume of mobile phones. So as we look at emerging markets, which are getting into it, particularly outside the traditional North American European market, people are not buying computers, people are buying phones. And not only that, but it is something that you don't need a computer room or a place in your house to put it. You carry it with you all of the time. So the phone becomes a personal device, and we're seeing that mobile adoption. The second demographic trend is age-driven. So millennials and Generation Xers in places like Europe, North America, and other places around the world are increasingly using their phone as their platform of choice as it becomes more powerful. So many of them, for example, don't have computers unless it's a laptop or a notebook, but primarily the mobile phone is the experience. In fact, it shows up that if a company does not have an effective mobile presence, they tend to turn off their clients. So in other words, if you don't think about your mobile experience in terms of in terms of reaching your customers, giving them a good experience, you get some pretty big numbers here. 57% are not going to recommend a business with a bad mobile site. 61% who say the mobile doesn't work, I'm going to go to the competitor's site. Again, that's just not acceptable in terms of making a business viable over the long term. And you see it reflected in the numbers. Look at those numbers. 57% of traffic comes from mobile devices. Email is a mobile device issue. Half of the U.S. shoppers buy on their mobile. 70% of mobile users take action with the hour. Why? Well, because it's right there. They don't have to go home to their computer. They can do everything in real time, immediately on their phone. We live in a rapidly changing world where we want instant responses. Phones produce that. What we're starting to see is that this is giving us better hardware. Now, what do we mean by better? Well, in many cases, it's giving us the same functionality as computers, but at a much cheaper cost, which means we get better market penetration. So it's a better hardware platform in terms of utilization for the average consumer, but also in terms of it's the platform that's out there that we want to focus on. And of course, what happens is we wind up being able to think about the different kinds of applications we've got, where we can do some kind of generic HTML down at the bottom there, which kind of goes to the web, it goes to the mobile, and we kind of get, because we're kind of compromising, we're getting kind of, sort of middling experience. We often will then look at various kinds of platforms, which are multi-platform. So there's a number of technologies to allow us to kind of take the similar application and put it in different environments. It does require coding. And then we have the native, which is a single platform with gives a really rich experience. There is a number of different factors that have to be considered in choosing the platform. And again, that comes back to the expertise. But just to notice that there is this categorization of applications. There's a lot of hybrid platforms that are coming up as people try to address the issue of doing a multi-platform kind of application rollout. Here are some of the ones that you can see: React Native, Ionic, Flutter. And again, this is the idea of why we kind of look at these things is because we are seeing this rise in support tools. The other thing that we're getting is big data. Remember, this is the feedback part. So we're getting close to 2 terabytes of data produced every second, and every 60 seconds we get all of these numbers here. You can just look at the incredible amount of information that's coming at us, and this is producing a lot of what we call the V's of big data. So volume, there's so much data being produced every minute. And we've also got the notion of value. How much of it can we actually is important to us? Veracity. How much can we trust? Visualization. There's so much data. How can we even understand it? As Clifford Stoll says, data is not knowledge. Data is not information. Information is not knowledge. Knowledge isn't wisdom. We've got to be able to pull something of value out of this sea of data that's coming to us with massive velocity. People are clicking and doing and choosing and posting so much that we've got a flood of data coming at us. And the other thing too is passing us so quickly. How much of it are we actually retaining in terms of viscosity and variety? It's not structured data. It's all unstructured. It's clicks and messages and videos and images. And how do we sort all of that? Well, increasingly, the big data tools are being turning to things like the big data tools that we use to manage all of this data, to pull those insights out for that MVP process to be able to understand what's going on. Increasingly are moving into the JavaScript space, so that JavaScript is also one of the things that we're looking at as being part of a big data solution. So what we're seeing in terms of a digital transformation is a number of factors: the rise of big data, the ubiquity of mobile, the rise of things like the rise of the Internet of Things, cloud computing. All of this stuff together is pushing us towards certain kinds of technologies that allow us to be able to leverage our assets in terms of people and skills and tools, to be able to produce very consistent and quick to market products and get valuable tools back. So we want to have tools that support that kind of very lean and rapid environment. And that's where JavaScript and Mean Stack is starting to come into it. So what happens is we get shippable increments. We're starting to get stuff we can put into the marketplace quickly. We're getting shorter timelines to our minimum viable product. It fits in nicely with agile methodologies, but because of this able to pull the big data back and other sorts of things, we wind up being able to focus on our customer outcomes. So one of the things that we do notice is that the world has rapidly changed. Technology is driving it. We're being said we're in the age of digital transformation, or the fourth industrial revolution. And as we look at it, one of the technologies that's empowering this mobile transformational approach is people moving towards a JavaScript mean stack kind of development tool set. Anyway, thank you very much.